Thank you. So good morning, everybody, and thank you for joining my presentation this morning. So over the last 6 months, I've been working on climate change vulnerability assessment on specifically marine food security in developing coastal communities with a specific case study in the Western Indian Ocean. So we know today that around the world, millions of people are suffering from hunger and malnutrition, and many of these people live along our coastlines where fish is a primary source of their food. So both in terms of their macronutrients, so protein as well as micronutrients. And we know as well that today climate change is likely to exacerbate problems facing these communities. And so a way in which these problems can be addressed and be put forward to governments and managers to create effective management strategies is through a social-ecological vulnerability assessment. So these assessments are already being conducted. However, most of the time are conducted at a national scale. All the studies are not specifically looking at food security. So my study is being to develop a framework of a social ecological vulnerability assessment looking specifically at food security at a local scale for developing coastal communities. And then the second objective of my study was then to operationalize the framework to a case study, which was then in the Western Indian Ocean in Tanzania specifically. So this is the framework which I've developed. I'll go through it slowly for everyone to understand. So the framework is an amalgamation and a reworking of previous frameworks which have been developed. So vulnerability is defined by 3 components, so exposure, sensitivity, and adaptive capacity. And then this is further subdivided by indicators to represent each of the components of vulnerability. So I'll go through each of these now. So exposure is defined as the direct effects of climate change on a system. So in my framework, I've defined exposure both in terms of the resource, so in terms of the actual fish and that are consumed as food, as well as the resource users, so the fishers who actually directly catch the fish. Then we have social sensitivity. So sensitivity in our case is defined as the dependence of the community on fishing. So this is both defined as directly, where fish is directly consumed as food, and indirectly, where the fish is caught and then sold as income to buy food. Then the third component of vulnerability is adaptive capacity. So here we've defined it using 6 indicators. So we have assets, which refers to the assets present in the community. Flexibility refers to the flexibility of the community to adapt to changes, such as switching to an alternate livelihood in the face of climate change. Social organization refers to the community structure, the governmental and the institutional organization of the communities. Learning refers to the fisheries management and the level of education and science used in fishing. And social cognition refers to the recognition of the causal agents affecting fishing operations by the local communities. And then the last component is gender, which of course is important to understand the gender equity present in the communities. So the framework which I've developed then has been operationalized in a case study. So the premise of the case study was we were able to obtain raw data from a survey which was conducted in 2018 on these 4 communities in Tanzania. So the names of Tanga, Pemba, Zanzibar, and Mafia. So the survey consisted of over 300 questions, interviewing 293 fishermen, and asking them various questions about their vulnerability at different aspects. So to complement this data for the framework, we also used expert opinion data from various fisheries experts. Life history trait data was taken from FishBase. Local ecological knowledge data, as well as external sources, were also used. So all of this data, which we were able to obtain, so such as the survey data, we had to extract key questions, I had to extract key questions which were the most significant and important, clean the data, and basically turn this qualitative survey data, and as well as all different types of data, into a uniform format, so qualitative into quantitative, to be able to compare different elements of both the social and the ecological system. So this was done in a variety of processes, which I don't have time to explain today. The data was then normalized based on the different types of data, weighted also based on various characteristics, and then aggregated to obtain final scores of vulnerability. So the scores range between 0 and 1, scores lower vulnerability, and scores closer to 1 indicate a higher vulnerability. So this is just a snapshot of one of the data sheets, one section of one of the data sheets, just to show you kind of where it looked, where we have the components, the indicators, sub-indicators, and the various types of data, and the method we use to obtain final quantitative scores to input. So then in terms of some results, so the results I'll show you today are just going to be some key results which highlight the importance of such a local scale granular study. I won't have time to show you all of them. So firstly, in terms of sensitivity, so if we remember, sensitivity is the dependence of the community on fish for both food and for income. So if we look at the figure first on the left, so this is a box plot which shows where all of the survey answers come from. So in the blue squares is where majority of the data is. So the first figure here on the left shows the proportion of fish which is eaten as a proportion of the total protein. So you can see across, for all 4 communities, majority of the data lies very close to almost 100%. So almost all of the community rely on fish as their primary source of protein. Then similarly for income, so this figure shows the income earned from fishing as a proportion of their total income. So you can see as well that across all 4 communities, they have a very high reliance on fishing for income. Then in terms of the ecological vulnerability, so this is the vulnerability of the actual species and the fish eaten by the communities. So through the survey, I was able to extract 3 key functional groups, which are the most important in terms of food security for the communities. So these are large pelagic fish, small pelagic fish, and coral reef fish. The pie charts on the right side of the slide show you the proportion of each functional group eaten by each community. So you can see that they do differ. And these proportions were then used to weight the vulnerability scores of each community. So I'll just give you an example here. So, for example, in Zanzibar, the resource adaptive capacity value was seen to be higher than the other 3 communities. So we found that this is due to the fact that this community, as you can see here, eats predominantly large pelagic fish. So through the data which I was able to use, so specifically for resource adaptive capacity, life history traits were used, such as migratory ability of the species. And because large pelagic fish have a high migratory ability, they have a higher adaptive capacity, and then this is reflected in the community's value. Then overall, the values for the overall vulnerability scores are shown in the map on the left. So you can see that across all communities, the final vulnerability score is relatively similar across. However, the drivers of the vulnerability differed for each community, and this is where it becomes important to look at the specific drivers to implement the most effective management strategies. So just as an example here, in Tanga, the fisher exposure was relatively low in comparison to the other 3 communities. So this could be driven by the fact that this community is a mainland community. In another case, the social adaptive capacity in Zanzibar was seen to be slightly higher than the other 3 communities. So this could possibly be due to the fact that this is a very touristic island. So this community has alternate livelihoods. The communities are potentially able to switch jobs and still then live under climate change impacts on their fishing. So this just shows you how different drivers of vulnerability are important, and looking at a local scale study is very useful. So based on a social ecological vulnerability assessment, you're able to draw out different areas of vulnerability, and which will allow you to implement different interventions based on your results. So you can have a social centric intervention or an eco-centric. So here I'll also just give you some examples. So for example, the community of Pemba was found to have an extremely low adaptive capacity. So this was specifically driven by the two components, assets and social organization. So in this community, an effective management or intervention would be to invest in the community infrastructure or community management. So this, for example, is a social intervention. Then in terms of an eco-centric intervention, so in Pemba, we found that the communities eat predominantly large coral reef fish. So in this community, an eco-centric intervention would be to implement potentially a marine protected area, which would enable regeneration of these stocks, which would enable, sustainable use of these stocks. Whereas, for example, in Zanzibar, this strategy may be less effective because they predominantly will eat large pelagics, which will not help to have a marine protected area. So here, a quota would maybe be a more effective intervention strategy. So overall, my study shows that how important a local scale study is to draw out key nuances between the communities, and where the most effective management strategies can be done. And it also is just important to note that the framework which I've developed and explained at the beginning is a replicable framework which can be then used in other studies around the world to look specifically at food security at a local scale. So thank you very much. I would just like to acknowledge my supervisor, Smits, for his unwavering support and assistance during my thesis, as well as my promoter, Elena Ojea, for her invaluable advice and assistance throughout my thesis, my colleagues at the Future Oceans Lab, the members of the Solstice Weir project for giving me access to their data, my family for their ongoing support, the CLOC project under which my research was done, and the IMBRC Coordination Office for all their hard work. So thank you very much.